So what we have going on today is one of the community members, Serge, who goes by the moniker Pew 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 Lasers on the Discord page, sent in a file with a fourth axis where they want to do a tool flip in the middle of it, and they wanted to have me look at it and see if there's anything that I could do to work through the file, give any notes, any hints, tips, tricks. So I'm going to walk through this file, start to finish, how I would potentially approach it, and go from there.
Just maybe a little bit of background. So the vice you see is this like self-aligning vice. It's not the normal four-jaw chuck. And this is quite literally like the first part I'm making using this vice. I made the adapter plate a couple of weeks back. But the thinking I had was that this would enable the ability to do flip parts in, I guess, any material, or really quite easily with the fourth axis because it's center aligned and whatever. But kind of in the process of putting this together, I realized there's a lot more caveats involved than I expected. One of the things that kind of worries me the most is how to work out the clearance between the vise and the spindle and all that part. I'm happy to have any kind of help on this one.
Talking about trying to figure out how to deal with a file where you want to know whether or not you're going to hit the vise. So I'm going to quickly simulate the file that I was sent and step through real quick. So if Serge was working with a Carvera with the laser attachment, you can see all of these red areas, it would smash directly into them, which is not great. Luckily, Serge is not working with the laser attached, so I quickly added a second simulation file that has the laser removed. And I will walk through exactly how to do that when I do the setup. But inside of here, you can see it still has a few areas where it could potentially crash, but we can fix those as time goes on. So the first thing I'm going to talk through is I know that there is a crash happening. And the way I would potentially fix that crash happening is by taking the stock a little bit further away from the chuck. You could also fix it by using a slightly longer tool and a few different other ways. So if I go into the design workspace, Serge has got this setup where there's the chuck and there's the part. So I'm going to part with the chuck and just pull it another 10 millimeters away. And I can check how long the part will need to be by clicking the inspect button and grabbing two sides. So it looks like you'd be looking for something around 87 to 90 millimeters of part with stick out. Yeah.
Right.
As you go through this, you would verify it a few different times with the machine simulation. So if I go back into the manufacture tab, regenerate the toolpath real quick.
I'm curious to hear your thoughts on where the optimal WCS, the work origin coordinate system. Do you agree with the use of it, the most furthest point, or should I maybe use the chuck as the WCS origin?
So long as your part is at least as long as the piece that's in fusion, it's probably better to use the end of the part just because it's easily accessible. Though it doesn't really matter so long as you set it up the same between fusion and your machine. So what we're talking about is in the setup, there's this work coordinate system here. That could have been anywhere along. So I'll talk through those as I do a new machine setup. Real quick, showing the simulate with machine. Running through the entire simulation right now of the toolpaths that I had generated earlier. Shows me that there aren't any collisions. There's no little red nicks on the bottom bar. And the verification issues, no issues found, has shown up at the top, meaning I can be pretty confident. I want to watch through the simulation a few times just to make sure. but I can be pretty confident that so long as the laser is not installed on the machine and the stock sticks this far out of the vise, I am not going to hit the vise with the machine. That is the power of simulation. So that's where we're going.
Did you need to do anything special for the simulation to know that hitting the chuck would be a problem, or is that
Yep.
what you're about to show?
We're going to walk through doing the setup from scratch. All right, so
Awesome.
in the Manufacture tab, creating a new setup. The machine is going to be the Carvera 4th axis harmonic community no laser version. This is the version that I created that doesn't have the laser module attached. And then operation is milling, or the work coordinate system. So I'm going to choose my work coordinate as z-axis and x-axis. So the first thing I select is my z-axis plane. That's any flat face to get the z-axis going up. And I'm going to choose my x-axis. I want that going through the center of the part, so anywhere there's a line parallel to the center of the part, click on that line. Come on, love. You can see the x-axis is going through the part, but it is reversed. So I'm going to flip the x-axis. So now I've got my coordinates correct. Z-axis is up, y-axis is away from me, and x-axis is through the center of the part. Anytime you're doing 4th axis work, this is kind of the setup that you want to do. That way you can touch off on the top of the spindle like you would normally do with a 4th axis part, and the Z height will be correct. Then we need to choose an origin point. So, coming down to the origin section, you choose model origin, selected point, model box point, stock box point. I'm going to start with stock box point and select. So I could choose the center of the part along this axis. I know from earlier in the setup in the design document that that center point there is the central axis of the chuck and the central axis of the A-axis. However, if it weren't there, I could choose various different options. So I could choose a model box point, and that is on the physical object, any of the model pieces. So again, I could choose a center point right there. That is a center of all of the 3D files that I've got open right now. Or I could go to selected point, and the selected point gives me flexibility to put my origin anywhere. So if I were not doing a 4th axis part, I could put the origin on any of these faces, centering on faces, so on and so forth. Or I could set it up on this axis here. Or if I were to ignore the warnings here, I'm going to go back into the Design tab and create a sketch. And I'm going to create a sketch on that face. I'm going to capture the position of the things I was doing earlier. So I've got a sketch here. So I could project any of the geometry I want. Say I wanted to line up my origin with this top face here. I could project any point on that top face. Project is the P key. And then I could project this center line here. Nope. Don't want to select that. So then, if I grab a line from the midpoint up and constrain horizontal from that point to that point, now I know this is the central axis of that part, the end of the part at the height at the top of my vise. Not super useful when you're doing a 4th axis part, but useful if you're doing a 3-axis part and say you're doing it inside of a collet chuck or inside of a vise. This allows you to manipulate exactly where that origin point is going to show up. So I have it drawn out in my sketch. I go to the Manufacture tab, back into my setup, and I could select my WCS origin, as that point right there.
That's cool. Would, yeah, it's a bit of an open-ended question. Could you imagine a scenario where you would want to do three-axis milling, but while the stock is held in the fork in the rotary module?
If you needed to pick up a specific feature on your fourth axis part that already existed
Mm,
as a Z0, so
yeah,
say I was milling on this face and the important part of what I was milling was in relation to that face. So I don't really care about the distance from the center line to the face. I care about the distance between this bottom face here and this top face here.
right.
Then I would choose to do that style of three-axis milling. Anytime you're doing work coordinate system points, those are what are called a datum. It's what you want to base all of your other measurements off of. And where accuracy matters from. So in this particular case, if you had already milled these two central bore axes, you might choose to create a sketch that puts a point that is in the center of this bore along the central axis of the fourth axis, so that you could pick up on that bore using a three-axis probe, and then everything else would be based off of that.
It sounds like it would be really useful if you're modifying something that you didn't design yourself.
Mm-hmm.
Yeah, awesome. Thanks. That's actually the kind of project that I'm most likely to work on.
Yeah, it's choosing your work coordinate system is super useful if you're modifying a part that already exists, or you're flipping over a part and you need to locate off of something specific. Like if it was super incredibly important that these bores lined up from both sides and everything was based off of those bores on both sides, then you would want to use that bore as your work coordinate system on side 2. Sweet. So we've chosen a point. I'm going to choose my model as just the model that I have out in the world right now. And to make sure that the chuck is that the simulation pays attention to the chuck, I'm going to set the chuck as a fixture. That allows me to do some things like add some clearance to the fixture. So if I want to always stay 5 millimeters away from the chuck, or if I want to be super safe, say 10 millimeters away from the chuck, I can add that information into this radial clearance or axial clearance, and that'll give me that information. So if I just really quickly select the parts of the chuck that matter, now when I do a machine simulation, it'll tell me if it hits that.
And obviously, maybe not obvious, but does it know about hitting the machine itself? Like in the machine sim, there's like that 3D representation of the Carvera. You would highlight that in red as well, right?
Yeah, if in the machine simulation, anything in the fixture section, if it hits it, it will highlight it. But the 3D sections here, any of these model aware operations, won't try to mill what the vise is. So if you had both the vise and the part in the model section, and you did a 3D adaptive clearing, and your stock covered both of them, then it would try to mill out this pocket in this vise, which it shouldn't do. So use fixtures for things that you don't want to mill into, but you still want to test if you're going to hit, and use models for the things you want to mill. Inside of stock, you had sent me some information about the piece of stock that you were planning on using. But if you hadn't, could jump in any type of stock, fixed size stock, relative size stock. I generally like using fixed size stock for anything where I know I've got a physical object that I'm going to be machining out of. If I don't know what I'm going to be machining out of at the end of the day, I'll probably use relative size stock. So if I was creating something where I'm cutting a small part out of a large sheet, I'll start off in relative size stock and say, oh, why are you doing that? Sorry, 1 second. There we go. I had clicked the wrong thing when I was, if you saw the stock was covering the vise as well, I had clicked the wrong thing when I was in model. I had accidentally set it to everything instead of just the piece that we're working on. So if I'm not really sure what's going on, I'll often start with relative size stock and add stock to the sides. So I could say add stock 15 millimeters each end, however I want to do it, and I'll switch back to fixed size. I'll take note of the measurements and switch back to fixed size stock. I just find fixed size stock is a little bit more robust over model changes, so I don't get myself into a situation where I change something in the model and suddenly things are different. However,
So
you sent me some information, so I'm going to use that information, which you had set up in the previous setup.
and then you can go yeah, that's really. I actually always thought preceding setup would also consider like what the milling operations have been done in the preceding setup, but it doesn't seem to do that. It just takes a side, right?
That is this button right here, Continue Rest
Oh,
Machining. So we'll do this when we go to side 2, so I can show you. It depends on exactly what I'm doing. If I'm going to use Continue Rest Machining, frequently I won't, just because it adds a bunch of extra processing time. But it is good to have for things like you're milling all 4 sides of something. Continue Rest Machining is super useful.
yeah, definitely. Maybe a bit of a tangent, but kind of related to this. What is your opinions on preparing the stock when it's in the fourth axis? When it's in three axis and I'm working with aluminium, I always, at least face the stock and make sure that it's, the important surfaces are flat and square. But I feel like that's not so important in this case, like there's only one face of the model that's actually touching the stock. So only that would really need to be faced, right?
Yeah, in this particular case, you want this side of the stock that's going into the vice jaws to be relatively square, just so that it sticks out and it's not terribly
On an
angled.
angle. Yeah.
However, with what you're doing with this piece, you've got a lot of leeway on either side of it that can be cut down. So you can be less accurate with parts if you're going to work on them from scratch, and if you're going to remove the face. Like if you're going to remove parts of the model, if you're going to remove parts from all 4 faces of the model, there's not really a reason to spend a lot of time facing the stock beforehand, because you will end up refacing it once it's in the 4th axis.
Yeah, exactly. To me, this is another really strong argument for doing, kind of flip parts or, smallish parts like this in the fourth axis now that it can hold the torque. Like, you don't need to prepare the stock, basically. Like, as long as it's straight enough, just chuck it in. Yeah.
Correct. All right, let's set up some machine simulation real quick. So, since we are using one of the files from the Carvera-Community profiles, I'll put a link into the chat and into the description of the video. But since we're using one of these profiles, we're already set up for machine simulation. So all of the work that's required to set up machine simulation and is done for us. The machine is ready to go. It has all of the pieces move correctly. The only thing we have to do is tell the machine simulation where our part is in relation to the machine. So in that case, I know that in my machine sim for 4th axis, the part position is the center of that chuck. So I'm going to switch this to part attachment selected point, and I'm going to grab something that is on that x-axis already. So I know that this chuck is got a central piece right here, already on the x-axis, already know it's going to spin around that point. And then I can drag it back and offset it away from the chuck however far I need to go. I'm not going to bother removing the chuck that's already on there. It's just more of a visual thing than anything that the chuck is there. So I've got my part, it's in position, it's got its preview machine set up, and I have a part in the chuck. Hit OK. And we have our setup.
The stock is like loading a little bit to the right. That's because you changed the stock size, or is that correct?
The stock is floating off a bit to the right because I didn't modify the stock size to go all the way to the vice jaws.
Yep.
That is more of a personal choice. I made the decision that I don't necessarily need to make the piece of stock go all the way in to the vice jaws, since I'm only cutting this section of it.
Gotcha.
And then I can test how long it should be, again with the inspect, grab the face it touches. It's about 95 millimeters apart, so on and so forth. So first up, when we're working on a part, generally you want to rough and then finish. So we're going to start with some roughing operations. For visual clarity, I'm going to turn off this sketch real quick. Also going to get rid of that. Yeah, that's much better. A little bit more room to play around in. So as we're working, I like to generally use some form of adaptive clearing for most of my roughing operations. And there's a couple of ways we can go about this. First thing we probably want to consider, or first thing you do when you do any roughing operation, is I'm going to start with an adaptive clearing. So I'm going to click the adaptive clearing, make sure my tool is correct, which the tools that you're using and you sent was a 17 millimeter. It's the DLC coded 3 flute, correct?
Yeah, it's 3 flute even though it says 2 flute. Yeah.
Yeah. So I might go in, I'll double click that. I'm going to switch it to feeds and speeds preset that you had created for deep aluminum. I'll walk through all of this in a second, but once you create a toolpath for the first time, best thing to do is just hit OK, and that puts it into your setups.
And you chose 3D adaptive here. Is there a reason why you did that instead of 2D adaptive, or is that a personal preference or something?
Yeah. So, choosing which of these two I wanted to go with. I'm going to... So, I have a model where I've got some slanted sides. I want to create a little staircase section on the slanted sides so I can finish it later. I also want to rough the top of these faces here. And there's a lot of operations I want to get done at once. I could go through and create 2D adaptive clearings for each of those operations. So I could do a 2D adaptive on this area here to clear out the center. I could do another one to clear off the tops of these. But 2D adaptive doesn't really understand sloped surfaces, and there's some things I want to do with those sloped surfaces.
Awesome. That was going to be my next question. Like a sloped surface and the cylindrical tool, how do you... Yeah.
Yeah, so if we go back to what you had sent me in, this is an example of if you were to do the 2D adaptive, and then your next tool path, you see there's a varying amount of material being taken off across the entire surface. So if I step here and then here, I will simulate this real quick. So if you had done a 2D adaptive, you step through and you can see it's got light cuts when it's at the top and heavy cuts when it's at the bottom for a finishing operation. And you want to avoid taking heavy cuts when you're doing a finishing operation, and you want to avoid taking cuts that are inconsistent when you're doing a finishing operation. So you want to get as close to the same width of cut, width of material, on both the XY plane and the Z plane when you're doing a finishing operation. I will go over that a bit more as we step through. So in this particular case, I chose a 3D adaptive. I hit OK. This is a hot mess. I'm going to start refining this toolpath. But since I had already set it up and hit OK, I can just go back and forth with OK. I can go in, edit something, hit OK, see it. If I don't like it, hit Control Z. Whereas if I had gone into a 3D adaptive, and then I went through, grabbed this, came into here, did a bunch of stuff in here, came into the linking tab, did a bunch of stuff in here, and I accidentally hit escape, all of that, all of the work that I had done before I hit escape would be completely lost. So it's always good to make the toolpath, hit OK, and then go in and edit it, and you can edit it in steps. I have a question. Would it make sense to have a setup that rotated the faces such that they're vertical? Then you're just removing radial stock.
I thought about this as well.
I can
and
show how to do that.
Don't you need the Fusion subscription to be able to do tool orient? Are you thinking of tool orientation? Is that the?
Yes.
Yeah, which you don't get if you're on free edition.
You are required to use the tool orientation to do it in the same setup, but I will show you how to do it in a different setup. So we do the setup in such a way that it is already, that you don't have to use the paid feature. So I'll show you two different ways of doing it. One where it is this vertical way, and then a more complicated way that doesn't use the paid version. And I can show you a third way that does use the paid version. It's not really much different than the way that I'm going to do it with the free version complicated. All right, so
there was another question. In the simulation heavy cuts? No, not in the simulation. The tool preview, toolpath preview. Heavy cuts, wide blue line. I believe blue is just normal toolpaths. Yellow is like rapid.
Yeah.
Is that right?
In this preview, blue is the tool is in the part and cutting. Yellow is a transitional move. So if you see here, the yellow is going up and then over, and then anytime it's touching the part, it's blue. If you see red is a linking move, usually a helix linking move or a ramp linking move. So if I set this up real quick, helix, see if I can get, so here the red is showing this is a ramp into the piece. Fusion doesn't have a good way of showing how wide of a cut that is being taken.
And green is transition as well, but
green is
kind of
another
linking.
type of linking move. Green is what is called a lead in or lead out. So if I go to the linking tab, there's these leads and transitions section. That's what these moves are. So it's either right when it's entering the piece or right when it's leaving the piece to go into one of the yellow rapid moves. So I've got a setup here. I'm going to do a few things to it. First off, I'm going to hit F7. F7 hides the toolpath preview that I've got going. Any of the type of visibility things that you want to play around with, if you come down into the bottom section, there's all sorts of different things. So you can turn on and off linking moves. So you can see yellow, the green is lead-ins, and blue is cutting moves. And you can show a bunch more information. But it is also on a hotkey, F7, turn it on and off. It's nice to have that ability just so you can see what the in-process stock looks like. Though I would not trust this green version for your final representation. I always simulate to see what the final look looks like. All right, let's start walking into these parts. Opening this up, the feeds and speeds, Let's test this real quick. Yeah, these are the feeds and speeds you sent with the original file. I'm not as familiar with this tool, and it seems like you've been having pretty good luck with them, right?
To be honest, I think I've tweaked a lot of that since putting in the motor controller, so we can just ignore the feeds and speeds for now, I suppose.
Okay. Cool. Then I'm just going to talk about toolpath generation for right now, and you can go back and modify feeds and speeds as you get more used to it. So, in my part, I'm going to jump into the Geometry tab. And in the Geometry tab, if you were in the 2D area, this is where you would be deciding, hey, I want to cut this section of the part. In the 3D section is instead, my 2D is I want to cut out this specific pocket. 3D is I want to cut out this area of the part. 3D is defining what you're not cutting. 2D is defining exactly what you are cutting. 3D is a lot more automatic and can do a lot more powerful things, but frequently you will go back to 2D for things where you really need specificity. Like you need to do one specific thing in a particular toolpath. Awesome. So stepping through this, in the geometry section, I'm going to choose a machining boundary. So if I had set this to none, it'll cut all of the stock. Anywhere that there's stock, it'll cut. If I instead set it to bounding box, it'll look at my model from the direction the cutter's looking at it and say, draw a rectangle around it. If instead I set it to silhouette, if this model had a cutout in it like that, instead, it would make my tool paths only inside of the area that is visible from the top. It's like a shadow graph.
So this is one of the bits that I kind of struggled with while I was using 2D paths, was I didn't know how to do tabs in 3D.
Yeah.
So I didn't want to cut the part out, flop on the floor. Yeah, that would work.
We're going to be generating a couple of tabs in a particular way. So there's that, and then there's also selection where you could draw a sketch or use a feature on the part. So if I only wanted to machine inside of this area with my 3D toolpath, it would only machine inside of this area. In this particular case, doing it this way would be almost exactly the same as machining with a 2D adaptive. I'm going to choose silhouette for this. The next section is how far outside of that silhouette do you want to go? Whether snip, dupe.
The tool has dimensions itself, yeah.
Yeah, the tool has dimensions. So if it's tool outside boundary, the tool will be able to go outside of that silhouette you've generated. Tool center on boundary, which is what it defaults to, and tool inside boundary are three different ways of defining exactly where the tool can and cannot go. In this particular instance, I'm going to choose tool outside boundary. And because I've been doing a little bit of playing with the file, I'm going to add a little bit of extra offset. I'm doing that so that when I'm machining this face here, I go a little bit past it for the finishing operation. So that the finishing operation, when it gets to the end of the part, doesn't just plow into something. I'll show you that here in a second. Stock definition is all fine, since we don't have any operations before this. And that's good. There's some advanced things you can do with the avoid and machine surfaces. I'm not going to go over that right now. And there's some advanced things you could do with the model section, which I'm also not going to go over right now. Next tab to jump into as we're walking through, I'm going to hit OK real quick so it saves all of the things I was just doing. It'll recalculate, but while it's recalculating, I can just double click it to cancel that recalculation. Is the heights tab. This is telling it where do you want to cut from to on the z-axis. In this particular case, I don't want to cut below this face here because I want to create a tab on the left side. So instead of choosing model bottom for the bottom height, I'm going to switch this to selection and select that face. I'm going to simulate this real quick just so you can see what's happening with that, or allow it to regenerate the toolpath. So if I pop out of F7 here, you can see I'm going past the part, but I'm leaving this little area here because I'm going to create a horizontal tab in the part right on this section. So I didn't want to get rid of that area. You can also see that I've gone past, turn the stock on and off. My part ends here and I go a little bit past it. This allows me when I'm doing the finishing operation to have a more consistent tool end position. I can go off the surface. And then the other advantage of the 3D toolpath is I have these stair steps, which is a much more consistent way of cutting when I do the finishing pass than if I were doing the earlier version where it was just cutting all the way up to the top surface when it was at the bottom. So it was cutting 6 millimeters when it was at the bottom and it was cutting 0.5 millimeter when it was at the top. Now when it's cutting the finishing toolpath, it's only cutting 0.5 millimeter every time it goes up. We can adjust that in the next tab. So right now this takes 22 minutes. In the passes tab, we can adjust some things. You have your optimal load, which is your step over. That is part of the feeds and speeds, so I'll leave that to your adjustments based on the cutting tool that you were using.
Yeah, I was using 0.3 with that brake fluid.
Awesome, so we'll switch that to 0.3. Cutting radius, machine cavities, setting it to climb, roughing step down of 7, and then the fine step down. This is where you choose how big of stair steps that it's making up those vertical surfaces. So if I were to switch this to 2 and hit OK, it should simulate a little bit faster, much faster. So now it's much bigger stair steps, but it went from 22 minutes to 6 minutes in the little timer that I've got here. If you haven't seen how that timer works, if you go into your profile, preferences, manufacture, show operation machining time, we'll turn on your little timers down here. Awesome. I'm going to leave it at a little bit smaller of a stair step. So coming back into here in the passes tab, I'm going to do this like a 1.5 millimeter. And then the stock to leave is also going to be how much of a bite that finishing pass is going to take. This is aluminum. You don't necessarily need 0.5 millimeter. So I'm going to switch this to 0.2 millimeters. And in this particular case, radial stock to leave is how much on the sidewalls it leaves, and axial stock to leave is how much on the floors it leaves. You want to leave a little bit when you're machining so that you can come in with a cleanup pass with a lot less tool pressure. Less tool pressure will give you a better surface finish so long as you are taking a large enough chip. So in this particular instance, I want to take about 1/4 millimeter off in any direction that I'm going when I'm on my finishing passes. That's enough so that it's actually creating chips and not rubbing or creating dust, but it's not too much to cause the tool to deflect. Down here, I could turn on fillets, which will round over the corners. Since I don't have any hard corners in this model, I don't need to worry about fillets. I could turn on smoothing, which loses a little bit of accuracy in favor of smaller file size and cleaner arcs. Again, we don't have any circular parts, so we don't need to worry about smoothing. And feed optimization determines if you're going into the corner of a part, it will slow down. So if you're noticing when you're running a program, it dives into a corner and your motor stalls and the tool deflects, so your corner looks terrible, your internal corner, turning on feed optimization can help with that. Last up is the linking tab, and inside of here, the defaults are all fine. If you hover over any of them, it'll give you a little bit more of a breakdown. If anybody has any questions over any of them later on in the video, let me know. I will be going over some of these features in different toolpaths as we go along. So I hit OK. It's going to generate my first toolpath. And there we go. So going off the edge here, going off the edge here. If I do a quick simulate, so it starts off the piece of stock, runs through the center of the stock, and then does the edges and the top.
Sorry, there was a question in chat. How do you decide how much retraction you need? And Speedkill says they notice that it appears to be a much larger default than is needed. Yeah, I think 5mm is default, which probably makes sense on a much larger like VNC or, you know, larger mill than Carvera. If I'm really optimizing something, I kind of change that to 1mm. What do you suggest that day?
If
Does it
you're
really
confident
matter?
in your, if you're not confident of the part and you're okay sacrificing machining time for safety, leaving it at the default is great. If you are more confident in the part and you know the top surface of the part is already flat and the stock that you're using isn't significantly taller than the stock that you had set up in Fusion, like if the stock in Fusion matches the stock that you're actually putting into the machine, then you can go 0.5 millimeter as low as you want. Yeah, 0.5 millimeter from stock top is about as far down as I would go on the first operation. Once you get into later operations where you've already milled away parts of it, you can get a bit more aggressive. So in the particular instance of this part, my first RFing operation touches every top surface of this part. Theoretically, when I am done with this first operation, anywhere along the top is already cleared and it's no longer there for me to hit. So in my first operation, I might leave my retracts a little higher, 2-3 millimeters. But then later, since I already know and I've personally verified that that stock is gone in the subsequent operations, I can reduce it.
And that might be something to keep in mind if you're not preparing the stock. You know, it's going to be what's the manufacturer.
Yeah, same thing in the linking tab. We're not using a ramp in this because we have the end of the part to work with. But if we were using a helix ramp, the ramp clearance height, if it's rough stock at the top, I'm going to leave the ramp clearance height relatively high. But in the next operation I do, I'm going to show you bringing that down significantly. So if I know I've already machined a surface and I'm just starting on this bore, actually let's do that. So I've done op 1, let's do op 2. I'm going to do these bores real quick. These ones, I'm going to do a 2D bore operation, grab those two faces. So same tool, same thing with speeds and feeds. Grab a bore operation. I've set it up, I hit OK. Open it back up, that just makes sure that it is saved. Geometry, I've selected my faces. In the heights section, so I know on this part that when you flip it over, those holes are done from both sides. If you can get away with it, and I know because of how thick this part is and how many flutes you have on your machine, I would set this to stock bottom and like minus 0.2 millimeters. I'm going to hit OK and then show you why. So if I flip over the part, from one side I've punched that all the way through. This helps if with any type of misalignment that might happen. If you were to need to flip the part and pick up something on the other side, it's good that you already have the bore. You could probe one bore, probe the other bore, make sure that they're parallel. You could put a couple of pins in the bores, put a parallel against the 2 pins, and sweep it with an indicator to make sure that those pins are parallel to your x-axis. There's a lot of useful things to having a feature transferred from one side to the other. It also leaves the bores much cleaner in this particular instance. Since anytime you flip a part over, there'll be a little bit of a ghost change in the tool cutting. So if you're doing the bore and you flip it over, where those 2 bores meet, there'll be just a tiny visual step, no matter what you do. If you do it from the same side, there won't be that tiny visual step. And you need to determine where that matters and where that doesn't matter. In this case, you can punch them all the way through. You might as well punch them all the way through. Going back into the heights tab, whole top is fine. So since we already did this adaptive clear, I know that this whole U-shaped section is already cut out. So I can start at the top of the hole and mill to the bottom of the hole. If I had not done the adaptive clear first and I wanted to mill these 2 holes, then I would choose stock top instead of hole top. So if I were to reverse this order and do the bore first,
as far as,
like
you know,
this.
kind of in that process of roughing, maybe finishing, where would you normally do a bore? Because I feel like you can nearly do it. It's like you don't need to do any finishing operations on it, right? It's normally quite accurate.
Depending on how accurate you need the bore to be. In this case, I suspect that these bores are clearance bores for a piece of hardware.
Exactly, yeah.
Which means that they can be done at any time. If these were bores that required me to put a pin in them, and that pin has to fit exactly, or I needed to press fit a pin into them, then I would do them in 2 operations. One is the roughing of the bore, and then one is the finishing of the bore. That way I can tune the finishing of the bore to whatever I need it to be.
Is there like a quick way other than just measuring to know whether your tool can actually go the entire way through the stock?
Again, with the inspect tool, you can grab wherever you're thinking about cutting. This is 11 millimeters. I know that your tool is 17 millimeters long. I also know that the stock on the top and bottom is half a millimeter, I think. So you've got 11 plus a half is 11.5 millimeters.
Easy.
Yeah. The inspect tool is super powerful. You can also grab a circle and it'll tell you what your radius and diameter are. You can grab a bore and it'll tell you all sorts of different information. You can set it to show you inches if you care about inches. Or if you're working in inches and you want to see millimeters at the same time. You can also grab any 2 faces and you can see from that point to that point is 5 3/4 millimeters. Awesome. So in the bore, again, we're skipping over feeds and speeds because you've got a bit stronger of a grasp on this particular mill. So we've done geometry, we've done heights. Coming to the passes tab, we're doing a bore, so we want to make sure we use a ramp angle. I like tuning down ramp angles a little bit when I'm using aluminum, between 1.2 and 1.7 degrees. It just gives it a little bit nicer of an entry and doesn't lose a lot of extra time. If you're noticing that it's cutting really happy at 1.5 degrees, it might be worth upping it for the different parts that you're using. Some end mills will do up to 2 degrees, some end mills will do 3 degrees. This is me being conservative. Me being conservative is 1.2 degrees, and then if I know the mill and I know how it operates, I'll bump that up until it starts being mad at me. Which is if it's starting to really slow down the motor. Amazing. In this case, if I were doing a bore and I needed it to be more accurate and I needed to do a finish pass, you'd set the stock to leave to an amount, 0.1 millimeters is fine, and then you finish the bore in a second operation without stock to leave. But this is a clearance hole. The tolerances on the hull aren't super critical. It's large enough. Hit OK, and it jumps through and does the bore. So we've done a couple of operations. This is sort of how you were setting up your file. There are a couple of operations you could consider. In this particular object, I know from how you've been setting it up that the sides and the front face don't seem terribly important as you were working through them.
Mm-hmm.
If they were, I would suggest going in and doing a 2D contour.
With an open chain to get like a U shape.
Same tool, grab a chain, grab open chain. I'm going to select that edge and that edge to get the U shape. See, it's going around 3 of the sides, but not all of the sides. I'm going to hit OK on that. You can see it's making our U shape. And then the heights, I'm going to do the height to selected contour, or no, to selection, and select this bottom face here. And in this particular instance, you don't have the flute length to go all the way through. So instead, I'm going to go a little bit beneath this surface so that it's ready for finishing, and you could chamfer. But but not all the way. So when you flip it, there will be a small step visible between those two. Why are you being weird? There we go. So if we go into our 2D chamfer, when you are done finishing this part, there will be a small, come here. Okay, the lighting's being a bit weird. There'll be a small step between where the other side matches this side, but it's the outside of the part. You can burnish that away with some sandpaper and no one will be any wiser. Really, what you're doing is you want to make sure that the important faces, which are this bottom face here. Yeah, your important faces are these faces here.
Yeah.
Everything else can be a little bit less accurate.
I think in the subsequent to sending you the file to, what I found was I could do a stock to leave on the outside on the first side, and then when I flip it over, there's enough flute length to do a finishing pass on the outside of that do that same kind of U open open chain, I think it's called.
Mm-hmm.
But there's just not enough flute length to do it all while it's got the full amount of stock.
Yeah. So if I were doing this particular type of operation, I am going to end up creating some slots, which are not amazing. A way to avoid that is you could go into the passes tab, turn on roughing passes, and have some step over. Should be 3.5. and then go into the linking tab and have a 1.5 degree ramp. This will take quite a while though.
Mm.
So you see this is 7. So you see now it's doing one toolpath and then a second toolpath. There are 2 red lines there.
And this is a good idea anyway, right? Because if you only did one, then the tool is touching both sides of the slot, which is not a happy place for the tool.
Yeah, it's nice to do a step over using the roughing passes because the first one that will happen is the one further away from the part, and that one will be touching both sides if it's a slot. But if it's not a slot, it won't be touching both sides. So I increased it a little bit more. I'd have to play with this for a little bit to get the exact value that you need to get rid of those sides. However, I have a different suggestion for how to clean up the sides of the part. Instead of doing it in 2 operations, one from the top, one from the bottom, doing it in 4 operations where you do one from the top, one from the bottom, and then you just go through and clean up the 2 different sides as their own operations would give you a much better surface finish on these faces. And also be much quicker. The ramping down into the stock with the side of the end mill can take quite a bit of time.
Yeah, that's because I think in the file that I have now on my computer, it's like 20 minutes just to do this U operation.
Mm-hmm. Since
And
those
then,
are just cleaning up a singular face, I'm not going to go over them. But it is, you set it up, you set your axes 90 degrees, and go from there.
yeah, I'm with you. And then the flute length also doesn't matter, so you don't need to worry about that either.
Correct. In terms of order of operations, going through the part, since it's in a 4th axis and you don't have to worry about flipping the part multiple times, I would honestly do all of the roughing operations first and then do all of the finishing operations.
Oh, as in all the rough operations on all of the sides and then all of the finishing.
Yes. That way, if
Oh,
a lot of extruded aluminums, as you're working with them, will tend to warp slightly when you remove large areas of stock. And it might be 0.05 or 0.1 millimeters. So long as it's within your amount of stock to leave before your finishing pass, you do all of your roughing, it warps slightly, and then you remove all of the warping that happened in the finishing pass. It is one
I
of
see.
the nice advantages of using a 4th axis for this instead of flipping the part. It's
I
less
see.
noticeable on thicker parts and significantly more noticeable on thinner parts. If you have
Yeah.
a 4 or 5 millimeter thick part or less, that thing will turn into a banana. If you heavily machine one side and you flip it over, it will be a banana.
Yeah. Just, yeah. I see the if you use Index Proto, if you use the indexed milling wizard, it does exactly as you've described. It does the roughing on all of the sides and then chains and does the finishing, which looks really weird in Desk Proto because it's still 4 setups, but it does the operations in a particular order.
Yeah. Awesome. So, in this particular setup, if I were to modify this where you're going from the sides, I would still keep this side being cut from top and bottom, but then I would do the 2 other sides as just finishing from 90 degrees and then 270 degrees.
Gotcha.
All right. So we've got that. I'm going to duplicate this toolpath really quick with a Control D because we have roughed out most of the parts of this model now. The only thing we haven't roughed out is the tab. So if I was doing this in multiple operations, I would do all of the heavy roughing, the roughing out this pocket, roughing out all of the 4 sides, Then I would go back and rough out the tab. The easiest way to do the tab is to go into the geometry, make a new open chain selection of this face here. And then we're going to lengthen it out a bit so it goes past the end of the model. I'm going to add 3 millimeters on either. Let's do 5. I'm going to add 5 millimeters on either side. So what happens, again, we've got our ramp from earlier with our 1.5 degree ramp. And we have our roughing passes with our step down. You don't necessarily need the roughing passes with the step down with this type of ramp, but it's good to keep them for a nicer finish. And our heights are, we're going just beneath the surface. So it'll come in and create a nice happy little slot here. When we do this from the other side, we're going to go in, leave another smaller slot, and then as the final operation, thin out the slot. I'll explain why when we do a few of the operations on the other side, but we're not going to repeat all of the operations on the other side. So we've got to the point where we're ready to finish. We did our adaptive to rough things out. We did our board to get the holes, 2D contour to clean up this face, 2D contour to rough in the slot while still maintaining a good amount of material. And then for finishing, I want to finish these flat faces first, mostly because this corner here goes down into that flat face. So if I want to finish the flat faces, I'm going to use the 3D tool paths horizontal. So I've made a horizontal, I've selected my tool, hit OK and see what it does. And honestly, in this particular instance, it's doing pretty good. I'm going to start off with clicking machine over holes. That will make sure that when it's doing the flat on the bottom, it just goes straight over where your two bores are. That's a nice feature to add in, just because if you don't do that, there might be a small amount of flashing around that hole, or it might try to toolpath around that hole, which can be kind of annoying. So if you see with the stock, I'm going to turn things, grab this and highlight this edge. You can see that the areas that are scalloped are outside the face, so we don't need to worry about them. So it's cleaned up this edge, it's cleaned up this edge. We have a little bit of flashing that's sticking up. We'll take care of that with our finishing pass on this flat face. But that covers cleaning up those different edges. And you see earlier it was moving around these holes, and now it's going straight over them. It's quicker, it's more efficient, and it leaves a better finish. When you get done, there'll be a slight striping pattern across the bottom instead of a chaotic mess. Then let's talk about finishing the last face that's going to happen in this particular part, and that's these angled faces. There are a number of ways of doing this. The way that you sent, which is to grab either a scallop or a contour tool path, 3D scallop or 3D contour. I'm going to use the 3D scallop or the 3D contour. In the geometry tab, switch to selection. No, not silhouette, selection. Thank you. Grab those two faces. And then I'm going to add a couple of different features. I'm going to switch to tool center on boundary is fine. We don't need to worry about contact boundary because we're using a flat tool right now. And the rest of this is fine. This isn't necessarily the way I would do it, so I'm just going to show you what it looks like at its base level. In the passes tab, I need to the maximum step down to like 0.2.
Yeah.
So when you're doing a contour this is the stair stepping that you get. Switch this to tool outsize boundary. Sorry.
That looks like layout.
Yeah, sorry, this is going really quick over this one. It's just, you know, you've been going for a while, and there's 3 different options. This is not the option I would necessarily choose. So you see it's got a stair step. If I shut off the toolpath, if you get real close up to the part, anytime you use a flat end mill doing a contour like this, you're always going to get a stair stepped pattern. You can run your fingernail over it, it makes a lovely noise. An alternative to using a flat bottomed end mill is if you instead go into your toolpath, select a different type of tool. I'm going to grab a ball end mill, ignoring feeds and speeds real quick. So I've got a ball end mill. It's all of the same selections. However, I am going to go into geometry and turn on contact point boundary. It's not super important for this because it is not an overhang, but anytime I'm using a ball end mill on a slanted surface, I like turning contact point boundary on. If you hover over it, it gives you a little bit of a informational dump about what's going on with the tool, on why it works and why it doesn't work. More or less, it just makes a nicer tool path with ball end mills to have contact point boundary on. The other one that I'm going to go into is in the passes tab. Since I'm using a ball end mill, I don't want to be cutting with the bottom of my ball end mill. So I'm going to order from bottom up instead of from top down.
Because at the bottom of an end mill, it's basically like 0 RPM, right? It's the worst point of end on.
But if I pop into part of the simulation, so if you see in the simulation as it's going, it is cutting with the side of the end mill, side of the ball of the end mill, not the very bottom. As you're going from the bottom up, the bottom is almost always clear of material, except for at the very, very bottom of the part. So that's why I choose that. The other thing that comes up and is a problem with this particular toolpath is since we're using a ball, we cannot get into this sharp corner. That might not be a big deal, depending on if you have large chamfers on the mating part that this goes into. If the chamfer is large enough to miss this section of the part. So if this here was mating into a part which looked like this, having the ball end mill not hit the corner, no big deal. If it was a tighter corner, it would be a problem. Anytime you have a sharp corner transition in any material, you want to relieve one or both sides. The way I would probably do it in this case would be grab a 2D contour on those two faces there, on those two edges there, go into the passes, and in the stock to leave, no axial stock to leave, but I'm going to add a -0.1 radial stock to leave. So again, radial is side to side, axial is up and down, and that will actually cut into where the model is designed. However, it also helps get rid of that little section there and relieve it so that the corners fit together well. I'm going to go...
The inner corners. They always get you.
Yep. Okay. So that's one way of doing it. You could also relieve a channel into the part here, if you cut lower on either side here before doing that slanted surface, then the ball end mill would be able to go up that entire surface. However, we're working with a 4-axis machine, and we should have the clearance to do it a different way, I think. So we're going to try it. The earlier suggestion of rotating the part in the setup. So I'm just going to duplicate the setup that's already done. So we've got setup 5, number 2. Go in here and yeah, I'm going to delete everything out of that setup and start editing the setup. So I made a duplicate. That's just so that I had all of my stock settings and all of my work origin settings correct. And then in this particular case, I've got my z-axis plane and x-axis. I'm going to change my z-axis plane to the face of that part, and it rotates it to match. So I hit OK.
Oh, that's brilliant.
Change my orientation. So you can see, and we're going to see if we can get away with this. The angle might not be good enough to do it, but we'll try.
Without doing maths, is there anywhere in Fusion where it tells you what the angle is now?
Inspect. Grab 119.4.
I'm very familiar with that same feature in Onshape. I use it all the time. I've never once used it in Fusion.
Yeah. I'm going to try doing we'll just see what happens if I grab flat. Hit OK. Also very true. So I'm going to go back into stock from here, turn on accessibility analysis. It says that it can probably reach the area. This accessibility analysis shows what is visible from above.
Assuming an end mill of 0 diameter, right? Yeah.
But also the edge of the end mill should be able to reach the red part. Let me shut off accessibility analysis real quick and go into stock, turn on continue rest machining so we can see what's happening. So I come in here and simulate. Oh, that was a ball end mill. I need to switch the tool back to the flat end mill.
Yeah. Now it's all a 90-degree flat surface.
So now it's a 90-degree flat surface. And do a quick simulate. You can see going in. Oh, it's going too far. So we'll have to bound the flat in the geometry tag, machining boundary, selection, grab the face, and tool outside boundary. That's just, I noticed it was going too far. It was cutting stock over here. So I just want to make it a smaller selection. Again, 3D operations, you were saying where not to cut. And give it a second to finish. Simulate with the machine. Play. What are you doing? Okay, there's a couple of headaches going on with the exact nature of the toolpath simulation. And this is why we simulate with machine. It looks like we have an issue with the stock that's sticking up here. Various different ways you could deal with this. You know it's there, you could cut that section down. Or, Matt in the chat made a suggestion, which I think is a great suggestion, where we're going to go back into this setup. what's the best way to do this? I'm going to create myself a quick manufacturing plane. So I'm going to go into the design section and make a plane at angle. Nope. Yeah. No, I do not want a plane at angle. I do. Oh, the heck with this. I'm going to create a sketch, project this line. Draw a line 90 degrees either direction. So now I have a line that is perpendicular to this face. And then I can construct a plane. I want two edges, this edge and that edge. Okay, so I went through and I made a plane that is 90 degrees to the face that I was working at. So that when I go back into the Manufacture tab and into my setup, my z-axis plane and x-axis, I can instead select that plane, which will once again rotate everything, and you have to get your mind wrapped around things. So I need to flip the z-axis there, and once again rotate weirdly. So now we can mill this with the side of the cutter instead of with the bottom of the cutter. So you'd be able to go into 2D contour, grab the flat end mill, select geometry, grab that surface. This is a finishing pass, so shut off rest machining this time. Yeah, turning on rest machining was a mistake. So then you can simulate with the machine, see if it crashes anything. You can see my verification showed up and it's all good. And I think I may have gotten my angle slightly correct, but you can spend a little bit more time fixing this plane so that the angles are all correct. But you could come down from the top, do a contour along that path.
There's so much they need to keep in your mind, though. Yeah.
It's one of the reasons that there aren't a lot of really good automatic machining setups yet, is there are so many variables and so many different ways to do things. Like, this is a very simple part, and I just showed you how to do one feature on it 3 different ways. And each of them have pros and cons. One of them, you don't have to rotate the part. One of them, you're working with the bottom of the end mill. One of them, you're working with the side of the end mill. The finishes between bottom and side of end mills can be different. It's wild. All right, so the last thing I want to do, if you were to go through and do this whole setup again on the opposite side of the part, so come in, flip the z-axis so that you do all of the same operations to get all of the milling parts done. The last thing I want to talk about is the tab.
Yep.
Which operation is the tab? I should have named it. Operation 4. Alright, so when I'm doing this part, when I'm doing the opposite side, say I've done all of my roughing, all of the things, I'm going back to where the contour happens. I'm going to go into my heights, select a surface here. It'll go 2 millimeters below that. So now between this one and the previous one, 2, 3, 4, simulate. I selected 2 operations in the yeah, I selected 2 different operations between 2 different setups on the left-hand side, and then right-clicked and hit simulate, and it will simulate both of them on the same part. When you're all done with your part, you can simulate all of your setups at once, and it'll show you your final part, which is pretty cool. So I'm actually going to slightly modify this to heights 1.
I was thinking you might need to model the tab, but this way you just keep simulating until you're happy with what you see. Like it's not.
Yeah. So what I would do is I would leave a relatively beefy tab for until the very end. This is might be a little too thin, honestly, for side 2. I just wanted to get. You could probably reduce these both down to 0.5 millimeter instead of the 2 millimeters that they are beneath those surfaces. That just allows you to go through and do any chamfering that you want to do on any of these edges.
Mm-hmm.
But you get to the point, you've done all of your finishing, you have a relatively beefy tab between the 2 of them. I would then cut the tab down to 0.5 millimeter thick from one side or the other side. 0.5 millimeter of aluminum at this width is enough that you can break it and then file it off. So from a 10,000 foot perspective, you go through, you do side 1 with the tab setup, however deep this goes. You do side 2 roughing, however deep side 2 roughing goes. Between the and so if I were to do this part, I would do the 2 90-degree sides first. So I would clean this face and this face up first, because they're quick roughing operations. They're not the most important dimensions, but it's good to get that material out of the way for everything else that's going on. And then I would rough side 1 and side 2, including the tabs. Once the roughing and the tabs are done, I would go through finish side 1 and side 2. At this point, we still have a 2-3 millimeter thick tab. Do any of the chamfering that you need to do. And then the last step would be from side 1, say, do another contour at the very end that cuts to 0.5 millimeter, 0.2 millimeters. You do it from one side because we are in open space and we're going to take advantages of some physics that are going on. So say we've got our tab coming up to there and we cut down, so it's a very, very thin section here. Any flex that happens when you're cutting from one side like this is going to create a torque moment, and it's going to bend the part down on this side, which will open that slot up. That way you're not screwing up any of the faces of your finished part. It'll just sort of slump over a little bit. You don't want to cut all the way through, because you could then, when you get to the very last section, it could kick the part and that could leave some scratches on it. You leave a very thin tab, just a couple of tenths of a millimeter, and then go in, work it up and down to material fatigue and break the part, or cut it with a saw and file and sand. And that's the part.
Brilliant.